Hi everyone, and this is day 4. We're going to be looking at how to solve equations with e and natural logs in it. And so we're going to look a little bit more of what those are. Right now we're not going to look at the front page. We're going to talk about that in class. So let's move right on to this value. The value of e is an irrational number, like pi. Pi is 3.14159, blah, 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 blah. E is 2.71828. And so you can think of e and pi as being the same type of irrational number. They are different numbers though. So if we sketch e to the x, and just so you guys know that we have these points, and this is from what I skipped, so I'll write them down for you guys. 0, 1, 1, 2.7, and 2.2, 7.4. And that's how I graphed y equals the e to the x. You can pause it and do that if you would, or please pause it and do that. Sketch a graph and state the domain and range. If we look at this, this is an exponential function, so we know that the domain is all real numbers. Again, it can be written as negative infinity to infinity, or x is an element of all real numbers. In the range, if we look at this, we know that there's an asymptote, a horizontal asymptote at y equals 0 in an exponential function without any transformation, so we know it's 0 to infinity, or y is greater than 0. And so the question here is, how does the graph of f of x, or e to the x, compare to 2 to the x? And we talked about 2 to the x last time. 2 to the x is the base of 2. This is the base of 2.72 approximately. You'll notice that the graph f of x grows at a faster rate, only because the base is larger. And so that's how they compare. They both are exponential functions. They're both exponential functions, and they both have horizontal asymptotes at y equals 0. And if we reflect the line, or if we reflect the function e to the x over the line y equals x, we know that we're going to get the inverse function. We've talked about that before. And so the resulting inverse function is in green here. Is referred to as log base e of x, or another way, because that's a long way to write it, you don't want to write this, is called the natural log of x. So ln of x is read as the natural log of x. And ln of x is the inverse of e to the x, and vice versa. E to the x is the inverse of ln of x. So that's an important thing to know, is that the natural ln of x is the inverse of e to the x, so natural log is the inverse of e to the x, and e to the x is the inverse of natural log. So moving on, another common base used in logarithms is base e, and we just talked about that. That's with natural log, is where e is an irrational constant. We've talked about that, e is being an irrational number. So now comes the important part. We know from above that ln of x equals log base e of x. If we convert into exponential form, if we convert into that, we know that e is the base. E to the log gives you exponents. So e to the ln of x equals x. Notice, and this is where everything starts to come together, e to the ln of x equals x. So notice that whatever the of ln portion is the answer, due to the fact that e is the inverse of natural log. So you're left, those two operations basically quote cancel. They don't, but we can think of it as that. And you're left with the whatever the of portion is of the ln. So let's look at this, and hopefully this will start to come together for you guys. ln of e, we can rewrite as log e of e, because the x is that, equals what? Well, e to the blank equals e to the first. It's a blank. Well, e to the blank equals e to the first. We know that ln of e equals 1, since it has to be 1. Let me write it like this. We know that this blank equals 1. Well, we know that we just tried to figure out, so we know that ln of e equals 1. Let's try it over here. I'm going to put a question mark here. Maybe that'll help here. Ln, we know that the natural log can be written as log base e. That's why we have it. So ln of e to the second, base e of e to the second, equals question mark. So we're going to convert into exponential form. E to the question mark equals e to the second. And what does that question mark have to be? That implies that the question mark has to equal 2. And you'll notice here, let's try one more. Why don't you guys try this one? So pause it and try that one. So hopefully you got that the question mark was supposed to be 4, so that ln of e to the 4th equals 4. So now let's look at the scenario here of these three problems. These three problems, ln of e equals 1, ln of e to the second equals 2, and ln of e to the 4th equals 4. Can you see the pattern here? What does ln of e to the x equal then? And hopefully you'll see that each one of these, the exponent, was the answer. This just equals x. And we already know this one. This one right here was done right here. I already showed you how to do that. So this equals x. Now, ln of 4 to the nearest thousandth, this is just done on the calculator. ln of 4 equals 1.386. So let's recap this entire process here. If you have ln of e to a blank, we know that that's going to equal the blank. Or e to the ln of blank, that's going to equal the blank. Natural logs and e's are inverses of each other. Just like 5 plus negative 5 are inverses of each other, they basically cancel each other out. The ln's and e's cancel each other out. And you're left with what is left after you have that. Remember that inverses, 1/2 times 2 over 1, these are all inverses. They are left with the identity portion of it. So, let's practice it. Now, we're going to go backwards a little bit here. This is a little out of order. This is what we talked about in the previous lesson. If ln of 3 equals x and ln of 4 equals y, we need to write in terms of x and y. So in terms of 3 and 4. So what does 9 equal? 9 equals 3 times 3. So I'm going to rewrite ln of 9 as ln of 3 times 3. Which then uses product rule to do ln of 3 plus ln of 3. Well, we know that ln of 3 is x. So x plus x, and that equals 2x. Again, this is product rule. The whole idea of doing this is to remember product rule. So I want you to pause the video and do B. You're going to be using quotient rule and power rule here, and I'll show you where we usually make a mistake after you try it. So the mistake that is usually done, usually everyone can see that 4 and the 12 can be 3 times 4 and the 4 stays on top. Then we're going to use quotient rule, subtraction, but this is where we usually forget things. You're subtracting the entire bottom, and therefore you need to remember that you're subtracting in parentheses the product of ln of 3 times 4, which is ln of 3 plus ln of 4. You then keep the parentheses, distribute when need be, and you're going to be left with just negative x. Let me show you B, and then I'm going to have you guys do A and C. So this is ln of B equals C, so we need to keep in terms of ln of B. Power rule, guys, do not forget the power rule here. Power rule states that if you have a natural log or log of any base raised to a power, the power comes out in front. So we can rewrite this as 2 ln of B equals 3 ln of B. And then therefore we know ln of B is C, so we're going to get 2C, oops, that's a plus there, plus 3C to get 5C. What I'd like you guys to do is pause it and do A and C, please. Hopefully you got 4C and negative 4C. For the last one, if you didn't, check it, please. For the last one, notice that we have a fraction here. With a fraction, where do we mess up is that we don't remember how to bring it to the top. The ln of b to the what? Negative 3. And that's how we bring it to the top. So therefore we're going to get negative 3 ln of b, and that is going to equal negative 3c. Sorry about that. Negative 3c. Moving on to solving natural logs. As I've said, I think solving exponential functions is where logs is used the most. And so you're going to have two different types, or three different types here. You'll notice that you have an ln, an e, and just a regular exponential function here. You know how to solve b. What you don't know is how to solve a and d here. So ln, we learned, and that's why I wrote it down, that e to the ln of anything equals that. Well, we want x by itself. Notice that we have the ln of x. So we need to take the e and raise it to both sides. The informal version that I'm going to call it is e-it. That's not the correct way to say it. We're going to take the base e and raise everything to base e. But usually in class you'll hear me just say that we're going to e-it. When we have e to the ln of x equals e to the 2.156, those are gone, and you're left with the x equals e to the 2.156. And that's it. That's the answer. We'll just go to D here. With D, notice that we also said that if you have e to something, what do you need to do to it? You need to take the ln of it. The ln of e to something equals that something. And so that's what we need to do here. But first, we need to isolate e. Okay? Get the correct spelling there. So we're going to subtract 1. 3 e to the 0.52x equals 36. Divide by 3. E to the 0.52 x equals 12. And now here comes the natural log portion. We have to take the natural logs just like we took, I should have done that in a different color. Just like we took the log of both sides, we need to take the natural log of both sides. So therefore, when we take the natural log of e, we're left with 0.52x equals ln of 12. And then to get x by itself, we'll divide by 0.52. And so you're left with your final answer to be x equals ln of 12 divided by 0.52. The next problem, e, we have e to the x, so you know you need to take the natural log of it. And notice you're going to get x to equal ln of negative 5. Well, here's the issue, and this is why I want to make sure we do this one. Can you have the natural log of a negative 5? And the answer is no. We talked about this in the previous, the domain in the previous page. The domain is 0 to infinity. And negative 5 is not in the domain of a natural log. And so therefore, the x does not exist. We have to reject this answer. And x does not exist. There is no value for that. What I would like you guys to do is try B. Let's just try B for class. So have B be done, and then we'll finish up the rest of it. And if you didn't understand this, please make sure and re-watch this or come see me during Ready Block. Have a good day.